What's up mga learners? It's me again, XerMar, and I would like to say thank you to everyone who watched my previous video lessons. And of course, I hope you will continue watching my videos, and I wish you will continue supporting me via this platform in teaching. And this time we have a new lesson which talk about to illustrate quadratic equations. First, we have to state our objectives. Number one, the learner is able to describe and identify quadratic equations. Second, we have the learner is able to identify or identifies the values of A, B, and C respectively. Alright, next we have what is quadratic equation. So let us define what is quadratic equation. In algebra, a quadratic equation came from Latin word quadratus, for square, is any equation in one variable of degree 2. In other words, a quadratic equation is a second degree equation. Meaning to say, in quadratic equation, the highest exponent of our variable is 2. Next, identify whether the equation is quadratic or not. And that is based on the definition given a while ago. So we have the first one, x squared minus 5x plus 3 equals 0. So is it quadratic or not? What do you think, guys? Alright, very good. That is quadratic. Why quadratic? Since the highest exponent of x is 2, and that is the requirement for quadratic equation. Next, number 2, we have x cubed minus 7x plus 9 equals 0. Okay, so is it quadratic or not? Okay, good. The answer is not quadratic. Why not quadratic? Because the highest exponent is 3. Okay, so next, number 3, we have 2x equals x minus 1. Okay, so quadratic or not? The answer is not quadratic. So number 3 is linear equation. Okay, the highest exponent is invisible 1. Number 4, we have the quantity of x plus 4 times the quantity of x minus 3 equals 0. And this is quadratic. Now, so later on we will discuss further about this one. This is another form of quadratic equation. So proceed. Standard form of quadratic equation. So the standard form of quadratic equation is we have ax squared plus bx plus c equals 0. Where x represents the unknown and a, b, and c are real numbers and a is not equal to 0. Why? If a equals 0, then the equation is linear, not quadratic, as there is no ax squared term. Next, in the equation ax squared plus bx plus c equals 0, ax squared is called what? That is the quadratic term. What about bx? Bx is the linear term, and our c is the, okay, good, the constant term. So again, in the equation ax squared plus bx plus c equals 0, a is located besides our x squared, and b is located besides x in the linear term, and we have the constant term, the number without any variable. That is the constant term. Okay? Examples of quadratic equation is standard form and identifying the value of a, b, and c. Okay, we have the first one. X squared plus 6x minus 10 equals 0. What would be the values of A, B, and C respectively? So first, the value of A is 1. So here, guys, take note, if you cannot see any number besides the term or the literal coefficient, meaning to say there is invisible one as numerical coefficient. So again, here the value of A is 1. Next, the value of B is 6. And we have the constant term as negative 10. Don't forget to indicate the sign. So negative 10 is the value of C. So here, you don't need to write the positive sign, okay, for the values of A and B. Next, number 2, 3x squared minus 7x minus 15 equals 0. And the value of A is 3. What about B? Okay, so the value of B is negative 7. And the value of C is, good, negative 15. Alright, proceed. Quadratic equations without B, X, C, or both. So meaning to say without the linear term, the constant term, or both linear and constant term are missing or lacking, and identifying the value of A, B, and C. So we have number 1, x squared minus 16 equals 0. So observe, we only have two terms in our equation, and those are the quadratic term and then the constant term. So now, what would be the value of A? So A is 1 again. And negative 16 is for C as constant term. And the lacking one is the linear term. So literally the value of B is 0. Okay, next, number 2. 3x squared minus 21x equals 0. So here, the only two terms are the quadratic terms and the linear terms or terms. So we don't have the constant term. So what would be the value of A? So A is 3. What about B? So B is negative 21. And of course, our C is literally 0. Next, number 3. X squared equals 0. Oh, we don't have a linear term and constant term. So we only have the quadratic term, and the value of A is 1. Okay, good. So 0 are the value of C and B. Okay, note, a quadratic equation lacking the linear term, constant term, or both is called incomplete quadratic equation, because the complete quadratic equation have or has quadratic term, which is ax squared, the linear term, which is bx, and the constant term, which is c. Next, we have quadratic equations in factored form. So here we go. Example, quantity of x minus 4 times quantity of x plus 5 equals 0. So now, in order to determine the values of a, b, and c, we should get the product of this binomial. So we will multiply quantity of x minus 4 to quantity x plus 5. But how? So we can get the product using FOIL method. But what is FOIL? FOIL is the mnemonic used in multiplying binomials, where F stands for the first term, O, outer term, I, inner term, and L is the last term. So here, we are going to multiply to get the product. So we will use the FOIL method. So first, we have to multiply the first term from each binomial. So we have x times x equals x squared. Next, for the outer term, we will multiply x times 5, and that is equals 5. Next, I, for the inner term, we will multiply negative 4 and x equals negative 4x. And for the last term, we have to multiply negative 4 times 5 equals 20. So we have these terms, and we will put them to an equation. So we have x squared plus 5x minus 4x minus 20 equals 0. So x squared positive, and we have 5x positive. Next, negative 4x, so minus, and we have negative 20, so minus again. So next, here in our equation, we have similar terms. So what are we going to do? So we will combine. So the similar terms are positive 5 and negative 4. Since our terms have different signs, so we will subtract and copy the sign of the number with higher absolute value. So our equation or new equation is x squared plus x minus 20 equals 0. Okay? So what would be the values of A, B, and C? So A is 1, B is 1, and C equals negative 20. Note, a variable without visible number has invisible 1 as numerical coefficient. Okay? So let us proceed. By the way, guys, here we can also get a product of two binomials using the happy face, okay, as what others do. But for me, I use FOIL method since the term or the terms are properly arranged. Okay, starting with the quadratic term, the linear terms, and then the constant term. Okay, so it's up to you guys if you will use the happy face method. Okay, next. Quadratic equations, not in standard form. So we have examples. Number 1, 11x squared plus 2x equals x squared minus 3. So observe, the left quantities, we have two terms, which are the quadratic term and then the linear term. Next, on the right side, we have x squared minus 3. So we have the quadratic term and the constant term. So here, we will apply the transposition property of equality. But I only deal with transposition. Since transposition, we only deal with the motion of terms. So, okay, so since from the right side, we have quadratic term, what we are going to do is to transpose this to the left side next to its similar term. Okay, so next to 11x squared, and negative 3 will be transposed next to 2x since this is constant term. So we have, okay, 11x squared minus x squared plus 2x plus 3 equals 0. So take note, guys, if we transpose, the sign will change. From positive will become negative and vice versa. So here we have similar terms, which are the quadratic terms. So we will combine. So 11x squared minus x squared is 10x squared plus 2x plus 3 equals 0. So identify the values of a, b, and c, and we have a equals 10, b equals 2, and c equals 3. Proceed with number 2. We have 2x times quantity of 4x minus 3 equals 9. So number 2 is different from number 1. So what are we going to do first? So we will expand the left quantity by multiplying 2x to the quantity of 4x minus 3. So we will multiply 2x times 4x, that is 8x squared, and 2x times 3, we have negative 6x, and equals 9. So be careful in multiplying, okay, especially the sign. Next. So we will transpose 9 to the left side to make our equation standard form. So we have x squared, or 8x squared minus 6x minus 9 equals 0. The values of a, b, and c are a equals 8, b equals negative 6, c equals negative 9. Next, number 3, we have quantity of 2x minus 1 squared equals negative 5. Observe, here we have a binomial raised to the power of 2. So, meaning to say, we're going to multiply the binomial to itself. So here, in order to expand or to get a product, we can use the FOIL method. But here, I will use the shortcut in squaring a binomial, because this is an example of squaring a binomial. So we have the steps in squaring binomial. Number 1, square the first term. Second, twice the product of terms. And third, square the last term. So we will apply. First, square the first term. So the first term is 2x. So we will multiply 2x to itself. So we have 2x times 2x equals 4x squared. Next, twice the product of terms. So we have 2 times 2x times negative 1. Okay? So the answer is negative 4x. And next, last, square the last term. So we have negative 1 times negative 1. And that is positive 1. And that is equal to negative 5. So again, we have 4x squared means 4x plus 1 equals negative 5. Next, we will transpose negative 5 to the left side next to positive 1. And negative 5 will become positive 5. So we have 4x squared minus 4x plus 1 plus 5 equals 0. So we will combine similar terms. The similar terms are 1 and 5. So we have 4x squared minus 4x plus 6 equals 0. And now we will identify the values of a, b, and c. And these are a equals 4, b equals negative 4, c equals 6. Okay? And that's the end. And I hope, guys, you are now able to identify quadratic equations, describe quadratic equation, and you are able to identify the values of a, b, and c. And reminder, guys, take note to some other quadratic equations, especially those that are not in standard form. Okay, so be careful in transposing the term, in expanding the term, and in combining similar like terms or similar terms. Okay, so guys, before I will officially end this lesson or session, I would like to share this simple quotation. If you fail today, then tomorrow is another day to succeed. And that is by XerMar. Thank you so much.